or we call it as regression analysis. The objective is actually to determine the relationship between one or more IVs on the 1DV. So you got 1DV example. In this particular case, we got some score. And then we want to identify the X's that can predict the Y. Not Y's, Y, because one Y only. Predict values of the dependent variable, which is Y, and then based on the value of independent variable X. That means your X can be 1 or your X can be more than 1. But your Y must be equal to 1. If you want your Y more than 1, you should embark another or complex analysis. We call it as multiple regression. Okay, so this is the assumption. We got the scatter plot. You learned already about R, which is the small r. The small r are actually talking about the correlation coefficient. But inside the regression model, you can derive the big R. What is the big R stand for? Multiple correlation coefficient. What is the different word between the small r and the big R? Multiple means more than one R. Because you can analyze the age, the income, and also the CGPA towards knowledge. Because all of that is many X's. Because we want to know which X's can predict which Y. Which is your Y is the knowledge of CPR. You got what I mean, You try your best to understand and listen it carefully. If you feel it need to be repeat over and over again, please let me know. Okay, inside your regression analysis, you are going to derive the regression equation and prediction equation. You are going to test the hypothesis. This is why I stated over there. Simple linear regression produce descriptive statistics that consists of 3 components. R, R square, and predictive equation. Another one will be producing for you is actually the table number 2. We call it as the model fit or regression model fit, and also slope. Slope is actually testing for your significant predictors. Okay, and then this is what we going to be produced. The computer are going to produce this kind of coefficient table. This coefficient table is actually generated automatically to give us the idea what is the composition of our predicted equation. So in this case, you can see y hat is equal to 7.533. Constant here is 7.533 is what? Is your intercept. What is intercept? Something goes to do something associated with the line that cross the line of the y. That's called intercept. Intercept faham Yang menyilang pada paksi y. Itu panggil intercept. And then we got the attitude, for example, as our x1. And then we got the motivation as our x2. So this is all the x's that we are talking about. And then we can see here the dependent variable is job satisfaction. So indirectly, the y hat here is actually located and also telling you about what? Job satisfaction is equal to 7.553 plus 0.184 kali or times by the attitude score of your respondent plus 0.884 times by the motivation score of your respondent. Then you can sort of predict the y hat. That is the beautiful of this linear regression. But you must make sure the model is fit, the regression equation is good, then you can use it. In fact, in this particular case, you can see the significant level is less than 0 or more than 0.05. It's more than 0.05. That means it's not a good significant predictors in this example. But this example, not for that. This example is actually just to tell you how you want to derive a predictive equation based on the coefficient table. You can derive it straight away. Take the constant, take the x1, take the x2. And majority of other statistical package also will produce a similarity like this. Other statistical package means what? You guna R ke, you guna stata ke, basically it will be the same. They give you the predicted equation, they give you the coefficient table, they give you also the ANOVA table. Okay, ni predicted equation. The first one, descriptive statistics. And then this is for the regression model. SPSS also are going to give you this table. We call it as the ANOVA. This ANOVA meant for what? It's meant for testing your model fit. So what is your null? What is your null? What is your null? Model not fit. What is your alternative? Model is fit. Or you can say that your null will be the model did not have the ability or did not have the sufficient evidence to be fit model. That is your null. Means that your null not fit lah. Your alternative will be the model are fit. Means that your X able to predict your Y. Okay, that is the trick. And then we got the slope. What is the hypothesis null for slope? There is no significant predictors, or we call it null, no prediction. But dia punya alternative will be vice versa lah. There is prediction of the X towards Y. Itu dipanggil sebagai slope. So slope, or also known as what? Just now I'm talking about the significant predictors. Because you got dua prediction kan? Attitude and also motivation. After that, we got the regression analysis, you got the multiple correlation coefficient, and you got the correlation of determination. Coefficient of determination is also known as R square. It's telling you how many variants explaining your Y based on the X. Okay. This is the hypothesis for the regression model, whether model not fit or not, which because of this. Kenapa dia kata null? It's equal to this one, beta naught plus E1. E1 is the error or the excess error. Apa yang kurang dekat H null kat sini? SLOPE. What is that? Slope. That means no slope, right? You tengok null there. No slope. What does that mean by no slope? Yes, no intercept. No intercept, no slopes. That means it cannot predict. That means it's not fit a model. That means the model not fit. Okay? That is what we call it as the regression model. The slope is beta naught is equal to 0, the slope is 0, or the slope is more than 0, or the slope is less than 0. You have the slope but positive or negative. This is about the slope, this is about the model. The model is fitting when you have the intercept. You have the intercept already, beta naught is intercept, but you don't have the X. You see? The X is actually indicate your slope. Okay? So model is talking about whether your model is fit or your model is not fit. Slope is talking about the predictors is significantly can predict or significantly cannot predict or cannot predict at all. Okay, let us go one by one. Don't worry, I have the example and I'm sure if you listen very carefully, you try your best to understand this topic. Okay, this is step number 1. We create the hypothesis and then we produce the relationship. Okay, this is additional analysis, correlation of determinants, amount of variance explain Y by X. That's mean how many this particular X can explain the occurrence of the Y. We are going to do that one after this. Relationship between X and Y is being justified based on the R, the big R. And then we are going to test for the slope. Okay, and then this particular slope is have this kind of conclusion. There is a significant relationship or there is no significant relationship. Okay, please bear in mind about this rejection and also the punya word. The model fit, there is significant relationship between IV and DV. Regression model does not fit. There is no significant relationships. Okay? Because after this, we are going to make the example. Are you ready? Okay, ready Right. Data were collected from randomly selected sample to determine relationship between average assignment score. This one. Assignment score and test score in statistics. Means what? In the learning process, sometimes you got assignment kan? And then you got final exam, right? So now we are trying our best to predict if the student get this kind of assignment score, what kind of final exam they will get. Okay, I made a repetition. In this example, actually, it's tell you what? It's telling you when you enroll any workshop or any kursus dekat dalam you punya candidature during your master degree. Using your undergraduate degree whatsoever, you have a lot of assignment, right? So this particular project or this particular example actually testing what kind of hypothesis. It's testing like this. This particular lecturer, let's say, want to know whatever score you got in the assignment will predict the occurrence of your test in the final exam. Okay? Kalau saya ada markah assignment macam gini dan saya ada markah macam gini untuk saya punya final test. So saya nak buat prediction lah. Dengan assignment contohnya 8 markah, berapa nanti final budak ni dapat? That is the idea. You got what I mean? Okay. You can change it accordingly lah based on your example after this. So now we have to go to variable. Please follow me. Go to the variable view and then please insert accordingly. The first one is assign and then the second one will be test. Please choose the new one. The new variable or the new sheets and then enter it accordingly. 8.5 and then 6 and then 9. So all this number is actually correspond to a student. Okay, this is a student number 4, this is student number 5, this is student number 6, this is student number 7, 7 and then 5 and then 6 and then 7.5 and last but not least is 5. So this is their assignment score and this is their final score that they gathered after they finish their enrollment to a specific subject lah ataupun specific course. Okay, you enter everything here. It's already entered. Okay, done. Oh my god, I left it behind one things, which is this one I think, 63 and then 85 and last but not least is 77. Okay, everybody done entering all the data. So now we are trying our best to make prediction. What is the prediction if you got this particular assignment and then what happened to your test? So I'm going to use this model. For example, I got this data from where? Let's say I'm teaching a biostatistics. I already understand this particular assignment already being conducted in 2018. This is the data. So I'm going to make a model. So based on this model, I want to test for my 2019 students, let's say. Okay, so how to do that? We proceed with the analyze, regression and go to the linear regression. Okay, after that, your dependence will be your test, right? And then your assignment will be your independence. Because we want to know, is there any relationship between these two? And our dependent here will be the test. Okay, derive the prediction equation. Tengok dia kata kat sini, data were collected and sample relationship between average assignment score and the test score. Distribution data is presented below. Alright, so the next one, I am not going to discuss any of it. I'm not going to click the statistic radio button, plot, save, option and style whatsoever. I'm just going to run it robustly. Robustly means that just run it straight away. Just to make sure you understand first the concept. Then we can customize later on. And then you hit the OK button. After you hit the OK button, what is being derived from the SPSS, it will become like this. Let me produce the output first. Analyze, regression, linear. Please insert this variable. The test variable should be your dependent. And then the assignment score should be independence. And after that, you click OK. This is a robust technique for the enter method for the linear regression models. Okay. So now I have to export this one first. Let me export it first so that we can discuss it more clearly. Okay, remember, in any analysis with regard to the linear regression, the first thing first, you have to remember in your mind, we have three things to discuss first. The first one is the prediction equation. The second one is the R value. The third one will be the R square. Where is that B? You can go here. You see? This is the assignment B. Assignment B means assignment and then noted by B lah. All requested variable entered. That means entered or removed by the SPSS is none. Nothing occurred lah because we just robustly entered. And then we got the model summary. Can you see the model summary here? What is that mean by this R and this R square? I'm telling you now. The R here show the correlation coefficient actually. If you run the correlation coefficient, you run the R, the small r, you will get the same thing. 0.85. If you don't believe me, you can try. You can go to this data. You see, analyze, correlate, bivariate. You just insert the assignment and test straight away. You can have the same thing, which is the 0.85. You see? Why is straight away? Why is not reduced or changes? Because you got one X and one Y only. That's why it's not changed. But if you got multiple X, this one slightly differ. Okay? So what does that mean by this R? This R actually talking about correlation coefficient. So the higher the value approaching the one indicate that it is highly correlated, right? Okay, that is you learn already in your correlation section. Now, the best important thing is actually looking for the R square. This is the R square, 0.748. What you want to derive from this information? You are going to extrapolate it according to the percentage value. So this one, you times by 100. You times by 100 means that you remove the point here, 1, 2, you can get here 74.8. 74.8% based on the assignment score ni, we can predict what happened in their final marks. You got what I mean? Is this a good model or not good model? I think it's good because 70% of it can already be predicting something on your final. That means if I receive the student assignment during 2019 and I mark them 8, I know that the final will be something to do with the higher marks, right? If I got 5, for example, I know that this student won't perform in their final. Something like that. Because the model suggests 74.8% already explaining your why by this particular X. Is a good X or not good X? It is good X. Only one can predict 70%. If you got 7, but below than this, it's not good model. That is the story. So now you understand or not the function of the R square, how we want to interpret? But the interpretation will be the variance explained of the X for the Y hat, which is the predicted Y. Which is the 74.8 is actually the variance of X explained to predict the Y. Okay? That's mean you got around, I would say if we round it up, we got 75%. So that means 75% of our X or our Y, how we want to predict the student final exam, 75% is already being predicted by the assignment. So another 25% will be predicted by what? By the numbers of your solat tahajud, example. By the number of your ta'at with your parent, for example. That score lah. That we do not calculate it. Who calculate it? The other researcher lah. Example yes, sir.
Would you use R square or adjusted R square?
Okay. That is a very good idea. When we use the R square, when we use the adjusted R square. Very good question. Usually, we use the R square per se if we do not compare the model with the other models. If we trying to compare our model with the different model or the different studies or the different approaches or different technique or different variables, then adjusted R square will be more prominent or will be more meaningful. Example, this one, I said that 2018 data. Let's say I have 2018, I have 2017, I have 2016. So based on this, I cannot use all the R square. I probably use my adjusted R square because it is much more standardized rather than the raw. This one is the raw. This one is actually being standardized. Okay. Adjusted R square is like that. It's being adjusted according to the variance lah actually. Okay. Now, we complete the first part, which is the descriptive part. Do you remember the descriptive part just now? R square, and then you are talking about the multiple correlation coefficient, the R, the big R. Selesai, khalas. But you left one more. What is that? PE. Very good. Prediction equation. Where you want to get those information, you go down here. You can see that 18.052 is our intercept, right? And then 8.257 is our X. So what is actually the equation will be derived? The equation will be derived something like this. Y is equal 18. Pandai. 18.052 plus 8.257 X. So your X will be assignment. Okay. So if I want to predict my students' final score based on the assignment, can I do that? Can. Based on their assignment score times by this value and plus this value, I will get their final marks automatically. You got what I mean? That is the idea of constructing a good model in the linear regression. However, finish on the equation, you have to answer another 2 elements, which is the first one, whether the model is fit or not, and significant predictors. Therefore, you go down here on the ANOVA table. This ANOVA table, ladies and gentlemen, is actually talking about whether your model is fit or not fit. What is the null? Model is not fit. That means you don't have the ability to predict the X towards Y. That is your null. What is the alternative? Model is fit. In bracket, the X have the ability to predict the Y. So in this particular table, I would like to ask you, you reject the null or you fail to reject the null? You reject the null. Because of what? Because of the significant levels of the F statistics here indicate the value of less than 0.05. Therefore, you reject the null. When you reject the null, what is left behind? Your alternative, right? Therefore, you make a conclusion based on your alternative. You got what I mean or you did not get? If you did not get, I'm going to write it up on a piece of blank sheet like this. So, what is your null? Your null will be model is not fit. Or indirectly, we already say X did not able to predict Y. Okay. And then what is your alternative? So your alternative will be model is fit. So in this case, you reject the null or you fail to reject the null? You reject the null, correct. If you reject the null, this is what left behind, and then you will see, you will say that the model is fit. The factor of the X able to predict the Y. Remember, the Y is actually not the absolute Y. The Y is actually what? Predicted values. It's not absolute values. It's a prediction values. So, settle on the second part of it. On my unrecognized whiteboard material over there, right? Model fit, the item number 2. You also cannot see from here. If you are Rabun, you cannot see anything. Oh my God, it's very hardly to be seen. But it's okay because already inside your notes. And then the last but not least is the coefficient table. The coefficient table is actually answering the slope. What is your null for slope? Null will be there is no significant predictors for this particular X towards Y. There is no significant predictors for this particular X towards Y. So if you can see here, the value of the significant is less than or more than. The null, there is no slope or there is no significant predictors of the X towards Y. There is null. Your alternative, there is significant predictors. Your null, there is no. Your alternative, there is significant predictors. So based on this, you reject the null or you fail to reject the null? You reject the null because the value of the significant levels here is less than 0.05. Therefore, you reject the null. When you reject the null, you are going to conclude there is a significant predictors of the X towards Y. Then complete your simple linear regression. These three things is already being explained in this slide. So don't worry. If you cannot capture it, I already captured the video and I also already captured it inside this particular slide. So if you run it, you enter the data, you enter all these things, you got this value, and then you can interpret it accordingly. This is the first one. Prediction equation. You are talking about 18.052 plus 8.257x, which is, this is what you will be derived based on your predicted equation. Okay, the first step. Descriptive statistic, talk about prediction equation. The second step is actually testing for the regression model. So what is the null? There is no model fit exists. Ataupun there is, the model is not fit. That is your null. So your alternative, the model is fit. You see this one? Since the F is less than 0.01, therefore we reject the null hypothesis, conclude that the regression model fits the data. That means the model, it fits the data. The model of the X towards predicting the Y is fitting. It's good lah, it's good fit. That means fits means sehat lah, sehat or bagus or good, something like that. Okay, the next one, the coefficient of determination. This is actually the descriptive.